Good afternoon. Today's tutorial will look at the story sheet which I've shared in the group, which is on nomenclature. Nomenclature of alkanes. But nomenclature of alkanes. Nomenclature of alkanes, we have question 1. Question 1, you've been asked to give the IUPAC as well as the common name. The common name is the listed outward group. Outward group, or draw the table. We have here the formula. Where we have the common name. Common name, here we are given the IUPAC name. Here we have to give the structure. Structure formula. The first one, we have been given H3C attached to this, and this we have this as the skeletal. Skeletal formula. So the common name for the first one we have been told is methyl. Methyl from the parent name methane. Now since it has lost one hydrogen, so this group at the end is replaced with YL. So the name we have methyl. So the IUPAC name still the same, methyl. The second skeletal structure we have been given this. So this one we start counting. This is where start counting 1, 2, 1, 2. So that is say we have 2 carbon. This carbon is bonded to a group here which is indicated by a star. So this the common name we have been told is ethyl. So same they what from the parent name, they then drop the NE, ANE, then you replace it with YL. And this one, the IUPAC name will still be ethyl. The structure formula we have 2 carbon 1, 2. So we have this one. This is the same one we have got the carbon attached to 3 hydrogen, and another carbon is attached to 2 hydrogen. So it's just written the bond line. This is to say that the carbon here to the end attached to 3 carbon. So in the formula we have 3 carbon, and we have 3 hydrogen, 1 carbon, and we have another carbon which is the for this one we have H2, 3, then this, the one which is bonded to this. So remove this. Come to the next one, which is this one. So, for the look at this, we have this carbon, we have the central carbon, attached to 4. 1, 2, 3, 1, 2, 3, 4. Attached to 4. So the carbon is balanced. So we have the carbon attached to 3 hydrogen. Attached to 3 hydrogen. So when writing the structure, we will say we have CH3. This. How many are they? 1, 2, 3. 3 is attached to 1 carbon. This carbon, the one that is attached to this other structure. But I will have this. I was just showing that this is what is happening. So we have this. So saying H3C, 3 of them attached to 1 carbon. So what is the common name? What is the common name for this? The common name for it 8-butyl. It will be butyl as a common name. This can be considered to be, we have 1, 2, 3, and you have this, 1, 2, 3 as the parent, then this one attached to it. So the name can be 1 methyl. We have 1 methyl, 1 methyl, 1, 2, 3, 1 methyl, isopropyl, 1 methyl isopropyl. Oh, this is 1 methyl isopropyl. This also can be 1 methyl. They are 1 methyl, 1 methyl. This 1 methyl is attached to 1 1 methyl, 1 methyl ethyl. One methyl isopropyl, 1, 2, 3. Then you have got what this methyl group. And so get 1, 2, 3 as a 3 carbon. That's where the isopropyl is coming from. Or we say I mean this one should have been 1, 1 dimethyl ethyl. 1, 1 dimethyl ethyl. These two, we take them as what? A substituent attached to carbon 1, and we have the parent, which is this 1, 2. So that's the ethyl. 1, 2 dimethyl ethyl. Or we say 1 methyl isopropyl. But the common name is tetrabutyl. The common name is tetrabutyl. I will have this. I go to number 4. Number 4, we have a skeletal structure of this one. So if you count the number of carbon, we have 1, 2, 3, 4. So just like I illustrated with the one that we have done, this is the same. Say that we have carbon, another carbon here, we have another carbon, another carbon. So E attached to it's attached to 3 hydrogen. E is attached to 2 hydrogen. E is attached to 3 hydrogen, and we have E attached to the this other group, and again they need to be 1 hydrogen. Because remember the carbon obey the octet rule, so it needs to have 8 number of electrons surrounding the carbon atom. So having this, we know that we can write the structure of we have CH. CH, this is where it's attached to the other group. We have this and CH3. This carbon CH2, and we have the CH3. This is the structural formula. Structure formula H3 carbon, which is this, and we have carbon and hydrogen, hydrogen and carbon. We have carbon and the 2 hydrogen, which are this, carbon and the 3 hydrogen, which are this. So that is how we are writing the structure formula. So the next one that are coming, I want the illustrative that too. So now we go to the common name. The common name We have how many carbon? 1, 2, 3. 1, 2, 3, 4. So this one we have iso, isobutyl. Iso means attach the middle, the structure. And the IUPAC name, still so YouTube. Next one. So this one that count here 1, 2, 3, 4. For the structure formula, we have H3, we have 1, 2, 3. Then this 2CH that's the and 1, 2, 3, 3. For this, we know that there are two hydrogen and E2 hydrogen attached. E2 hydrogen attached. So 1, 2, 3, just like CH2, 3, meaning these 3 carbon which are here. The common name we have been given N-butyl. N-butyl, the IUPAC name still be the same. We have the butyl. N-butyl. The other structure that we have, this one. But this has got how many carbon? 1, 2, 3, 4. So with this E, so we have 3, then we have a methyl group. CH3, this is attached to H3 attached to H2C attached to this, which is only one only one hydrogen. Only one hydrogen to make the carbon to have octet, to obtain the octet group. So this carbon now, the H2C, then attached to this, now the structure will be the structure formula. And the common name We have 1, 2, 3. 1, 2, 3. So for this, you can get 1, 2, 3. Say isopropyl, isopropyl, methyl, isopropyl, methyl, and we have the iupac name, which is for the long chain 1, 2, 3. So we have one carbon 2. Carbon 2, we have 2 methyl, 1, 2, 3, which is propyl. Because this 1, 2, 3, this take this as isopropyl and methyl for the single carbon, which is the common name. But for the iupac name, we have one follow the long chain, which is the parent name, which is the isopropyl, and we have the on carbon 2, that's where the methyl group is attached. Ahora, please. For the first one, you've just been given the structure formula. Structure formula, we have CH3, CH2, CH2, CH3. So this is where CH3, CH2, CH2 attached to this. 1, 2, 3. Because here we know that there are 3 hydrogen, 2 hydrogen, and 2 hydrogen here as well, which are attached to this. But in this case, we are just writing the bond line that's 1, 2, 3. The common name we have been given, which is N-propyl. And with it, it will be the same. We have the N-propyl. That's on question 1. Question 1. Go to question number 2. And then give the iupac name of each of the following alkanes. Remember, we're looking at the nomenclature of alkanes. Nomenclature of alkane, I've shared in the group the Excel sheet that we are looking at. Done with question 1, we go to question 2. Provide the iupac name. Question 2. We have 1, 2, 3. 1, 2, 3, 4, 5, 7, 8. And on each carbon, we have this. Provide the iupac name. And this is question 2. Question 2A. Question 2A. Before we give the name, we need to count the number of carbon. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. So see that this is the longest chain. This is the longest chain with 8 carbon, and this will carry the what? The parent name. The parent name for 8 carbon. 8 carbon, we have octane. Octane, that's the parent name. Then this group will be a substituent. So it's attached to, we can set the numbering from this point. We start from here. We have 1, 2, 3, 4, 5, 6, 7, 8. But you can also start from this side. We have 1, 2, 3, 4, 5, 6, 7, 8. And this group which we have, this group that we have, we just got how many carbon? 1, 2, 3, 3 carbon. So this can be iso, which is number 3 from number 3 on question number 3 part 4. Number 3 part 4, we have this structure. And the common name said is isopropyl. Isopropyl, and the IUPAC name is 1 methyl, 1 methyl ethyl, 1 methyl ethyl. This group. So from this, we have the IUPAC name. The IUPAC name for this structure now would be 1 methyl, 1 methyl ethyl, 1 methyl ethyl octane, 1 methyl ethyl octane. But to use the common name of iso, actually, the name would be some carbon number 4. The counting, because we get the one that will give us a smaller number, the substituent that we want to be. So set the number is from the light. So 4, carbon number 4, we have 1 methyl, 1 methyl ethyl, 1 methyl ethyl octane. So we say 4 isopropyl, 4 isopropyl octane, 4 isopropyl octane. For B, we have 1, 2, 3, we have B. So if you have to count the longest chain, 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5. So that either way you count, it still gives you 6 carbon. 6 carbon. So if you take this one as the longest chain, take this one, the longest chain. So we have this group as a substituent. Which is has got 2 carbon, and the 2 carbon we have ethyl. Ethyl group. Now the numbering matters. We can start counting from here. From here we say 1, 2, 3, 4, 5, 6. We start from here 1, 2, 3, 4, 5, 6. The one that is giving us a smaller number for the substituent, that's the base counting. That's the counting we'll get. So here, if we start from this side, from the right, we have 3. That's from the left. That is to my left. That's to my left. From this side to the substituent is carbon number 4. But from my right, that the substituent is on carbon number 3. So I'll say 3 ethyl, and we have got 6 carbon. That's the hexane, which is 3 ethyl, 3 ethyl, hexane. 3 ethyl hexane. That's the iopacane. I'm not going to finish all of them. I'll jump to question 2I. Question 2I. These are the exercise for you. Solve them where you have a challenge. Please, you're free to ask. If you look at question 2I, yeah, this cyclic group, and yeah, this, look at this. The parent chain has got 6 carbon atoms. 1, 2, 3, 4, 5, 6. Attached 1, 2, 3, 4, 1, 2. So the cyclic form. This is the hexane with 6 carbon. 6 carbon. This group, which is we know that this is ethyl, and this group, which is the 1, 2, 3, 4, which is say isobutyl. In the isobutyl, or we say 1, 2, 3, which is 1 methyl, 1 methyl, 1 methyl propyl, 1 methyl propyl, 1, 2, 3. So the name, give it a name. The iopacane name will be now the numbering. The numbering, we can start from here. We can start from here. Say 1, 2, 3. We start from here. We have 1, 2, 3, 4, 5, 6. If you start from here, we have 1, 2, 3, 4, 5, 6. Or we start from here. We have 1, 2, 3, 4, 5, 6. So the best one we have seen it. If we start from here, this group will have a substituent of a number of 2 plus this other group will have 6. So if you add, give us 8. Okay, start from here. I move clockwise. This group will have 1. This group will have 5. So total giving us 6. But if I start from this point, I move anti-clockwise. This group will have number 1. This group will have number 3. And the total we have 4. So we follow the one that is giving us the if number. So the numbering, the correct numbering would be In this case, the correct numbering in this case will be start from 1, 2, 3. So and I started from this one instead of this, because I look at the priority. This one, the more number the alkyl group, the alkyl group has, the more priority to have. So this one has 4 carbon, has more priority than carbon 2. So in this case, I start from the 1, 2. So I'll say, and we have I'll say we have 3 ethyl, 3 ethyl, and we have 1 in bracket. I say 1 methyl, 1 methyl propyl, 1 methyl propyl, and this cyclo. Cyclohexane. 1 methyl propyl, which is 1 methyl propyl cyclohexane, or say 3 ethyl, and we have 1 isobutyl. Isobutyl cyclohexane. So from here, I'll go to question 2. Question 2, which is asking question 3, which is asking to write the structure when you have been given the aliphatic name. Question 3. For A, we have 2, 2, 4. We have the primitive pentane. Primitive pentane. The parent has got 5 carbons, so start from 1, 2, 3, 4, 5. Primitive pentane 2. If I start from here, 1, 2, I have 2 methyl, 2, 3, and then 4, and I have another one there. So that the name goes to 2, 2,4 methyl pentane. You have got 2 on carbon number 2 and 1 on carbon number 4. So if this one, if you are to write the structure, you have been told to write the structure formula. The structure formula. So if this will say CH3, and we have got this CH3, CH3, 2. Then here we have one carbon. One carbon. The next we have CH2. CH2. We have CH3 attached to CH. CH, and then we have CH, CH3. This will be the structure, the structure formula of this compound. So this one I just wrote it as a skeletal formula. The skeletal formula. From the skeletal formula, it will be very easy for me now to write the structure formula. Or if you want, you can just get it direct for me, able to write the structure formula. But if you present it in what the skeletal formula, it will be very easy now to change the structure formula. The next one we have been given is which is question 3b. Question 3b, we have cyclopentane. 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 This one, cycle. We have 5 carbon. So we have 1, 2, 3. If you look at question 3F, question 3F, which is propylbenzene. Propylbenzene. Benzene, you know that benzene ring, 6 carbon, and we have it. And propyl, this is to show that it's attached to the benzene ring. So whatever it's been attached to, since it's the only substituent, wherever it's been attached to, then it will have that carbon will be counted as carbon number 1. And propyl group, we have it is 1, 2, 3. So 1, 2, 3, which is the propyl attached to the benzene. The benzene. So this where I could write the structure formula, which is 1, this, which is CH3, 2, CH2. In short, you can just write to say CH2 and 2. Then we have We have how many carbon? We have 6 carbon. Because with this we have hydrogen. One hydrogen, here there is no hydrogen. So we can just count 1, 2, 3, 4, 5. So we have 6 carbon, 1, 2, 3, 4, 5. 6 as well as 5. Because for this, you know that the 6 carbon and the 5 hydrogen will give us a benzene. Even the one that you're from doing, which was cyclopentane, which was this cyclopentane. This one, count the number of carbon that we have. We have 1, 2, 3, 4, 5, and each there are 2 hydrogens. So 2, 4, 6, 8, 10. So we have 5 and 10 hydrogens. That's we create the structure for it, the structure formula. Quickly we go to question 4. The rest of the question.
Oh, Mr. George.
Yes.
Yeah, is it necessary that we light those hydrogens when lighting the structure?
No, not necessary. Not necessary. I was just writing just to help us understand how we write the structure.
Okay.
But with it, you know that these are carbon, and the carbon they are attached to it. There are specific number of hydrogen attached to it.
Okay.
But
Right.
the hydrogen, I was just writing them just to help us to understand what is happening.
Okay, thank you, sir.
Yes. So we look at question 4. Question 4. Draw the bond line structure for the following compound. Question 4A. CH3. H. Write the bond line formula. Missed out one carbon. There was carbon. And so this CH3, 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 that is they're talking about. We have a carbon here bonded to 3 carbon, which is this one, then bonded to this carbon. This carbon one, 1, 2, 3, 4. 1, 2, 3, 4. And the 4 bonds to the OH group. So the bond line just be this. Okay, like that. So this one was just to help us come up to this. And remember, when writing the bond line, the hydrogen and the carbon are just indicated just by a line. But in a case where we have an atom other than carbon and hydrogen, that one we need to indicate. This one we need to indicate if the atom is other than carbon or hydrogen. Go to 4B. CH3, CH2, CH, and we have CH3, CH2, COOH. This one at the bond. CH3, meaning we have a carbon attached to 3 hydrogen, is attached to another carbon, which is attached to 2 hydrogen, attached to this, which is attached to 1 hydrogen, and we have this. And the next one, we have this carbon attached to 2 hydrogen. And the other one that we have for this carbon which is attached to this group attached to the carbon carboxyl group. The carboxyl group, we have this, where this. So our bond line formula just be 1, 2, 3, 4. 1, 2, 3, 4. And then we have this. This H. And then here we have a methyl group. So that's our bond line. CH3, which is this one. So we have CH3, which is this, CH2, we have this, and the CH, which is one carbon bonded to hydrogen and the methyl group. And the next one you have the CH2, which is this one bonded to attached to the carboxyl group. Question 4C, similar to the one that we have done. I'll go to question 4D. Question 4D, we have CH2, 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 CH3. So for this one, the bond line, we have CH2, the two hydrogen, this bonded to CH, one hydrogen, and here we've been told we have a double bond. And the next one, we have CH and the two hydrogen, bonded to this one, two hydrogen, yeah, this one, carbon, one hydrogen, the double bond. Then we have CH, one hydrogen, this one with three hydrogen. So the bond line in this case we have 1, 2, 3, 4, 5, 7. 1, 2, 3, 4, 4, 5, 7. 1, 2, 3, 4, 5, 6, 7. Carbon of one, we have a double bond, and on this carbon, we have another double bond. So that's our bond line. So this carbon obey the octet rule. So we have 8 electrons surrounding it. 2, 4, 6, 8. That's why we only have one carbon attached to it. Here we have 2, 4, 6, 8. That's why it has got 2 hydrogen attached to it. Same way we have only one carbon because we have 6 number of electron make plus the 2 make it 8. Question 5. What is incorrect about each of the following names? For each, suggest the correct name. Each suggest the correct name. Question 5. Question 5A. You have 3A. 3 benzene. 3 benzene. So the bench means 5, and this means we are talking about a double bond. A double bond. These 3 staying at the position where the double bond is. So we have 1, 2, 3, 4, 5. And this staying at the double bond is on carbon number 3. 1, 2, 3. So number 3, we have double bond. So now the question is, what is incorrect about each of the following names? For each, suggest the correct name. So with this, what is incorrect about it? The numbering, if you start from here, we have 1, 2, 3, 4, 5. So starting from my left, the double bond that is on carbon number 3. But if I start from my right, this side, which is 1, 2, 3, 4, 5. The double bond is on carbon carbon number 2. Here it's on carbon number 3. So we give the double bond, we give it the name. The one that we give it is what the last the least number. So from this, the wrong thing about this is numbering. Numbering should have started from the light, so that we have carbon number 2. So the best name would have been 2 pentene. Are we okay on that one? Okay, let's move to.
Yes, sir.
Yes. You have a question?
No, sir.
Okay. So we have 2 methyl. 2 methyl. 2 methyl. 2 butene. Butene. This is the parent. Showing the longest chain. The longest chain. The longest chain, this showing 4, and we have this, which is showing that we are talking about the triple bond. And the triple bond is on carbon number 2. And to this parent, the butene, we have methyl, which is attached on carbon number 2. So I would like the we have 4 carbon, which is 1, 2, 3, 4. And then carbon number 2, start from me. 1, 2. We have a methyl group, and I've been told on carbon number 2, we have a triple bond, which is this, which is from this side 1, 2, 2, 3, 4. Is there anything wrong about this? Because you have been told what is incorrect about each of the following name, and for it suggest the name.
I think the number of bonds
The number of bonds.
on carbon 2.
Exactly. Because if I write it, T, it's we have carbon is attached to this 1, 2, 3, and to this we have this carbon attached to another carbon, and to this we have this. The group is carbon. It's carbon. Know that carbon obey the octet rule. So it has 2, 4, 6, 8. 6 electrons are shared in the triple bond. 6 electrons are shared in the triple bond. Plus this one. So we're talking about 10. We're talking about 10. Now, what would be the they say suggest, for it suggests the correct name. What would be the correct name for this? Because this is not possible unless you have removed the this group A, so that just remain the two butene. Because know that the carbon, yes.
So the final name will be 2-butene.
Yeah, 2-butene. The methyl group not supposed to be A.
Okay, so the thing that is wrong with this is the methyl group.
Yeah, what's wrong is what like you said, the number of the bond. The bond, this has got 5 bonds attached to it, which is not possible for carbon because it cannot violate the octet rule. And so the best is that this group not be there.
So on that question, which said identify what's wrong, so we're supposed to say is the methyl group or the number of bonds?
The number of bonds is what is wrong. The number of bonds, so the number of bonds is what is wrong. So this can be this, or it's only of the double bonds. If it has the double bond, it's okay. For the double bond, know that we have 2, 4, 6, 8. But either the methyl group is not here, or we move from the triple bond, come to the double bond.
Okay, sir.
So that the name now come to 2-methyl, 2-butane. Butane. I'll leave the 2 question for you so that you can look at question 6. But if you have a challenge there, you have to. Question 6. We have 1. So if we look at because down here it's the same tutorship group. We have been given the UPAC system of nomenclature, the priority list to determine the principal functional group. The priority list. If you look at this functional group, we have NH2 and C. See that this one has more priority as to compared to this. So the numbering in this case, we are starting from this. We have 1, 2, 3, 4, 5, 6. 6. 1, 2, 3. So this has got 3. In this case,
Yes, sir, sorry.
yes.
On the group there, is it the double bond that is there on the hydroxyl group, second last?
Yes. Is a double bond. Is a double bond here. The double bond. This is of the carboxyl group. Carboxyl group. This carbon to the carbon attached to a double bond, and then one oxygen in it.
Okay, thank you, sir.
That's why we have this. So this, since it has more priority, the numbering will start from this carbon going to the left. So the name this group which is this priority compared to this, we have 2 amine, actually 3 amine, then we have got hexene. We have hexanoic. We have hexanoic acid. So from the parent name thing, we have removed this and replaced it with the oil. And so we have hexanoic acid. What I mean hexanoic acid. If you look at B, if you look at question 6, question 6B, question 6B, we have this. H group. We have this. So with this group, which is the this is an ester. Ester, the parent name of the alkene, this we place it with the H. So in this case, we have how many carbon? 1, 2, 3. 3. So to 3 we have which is propane. Now this we have I mean not this. We say propanite and the H. So this, which means just from this point. So this group, which is the so say ethyl 1, 2 night. Actually, I was reading out this say O A it is so proper. It's a few propanoid. A few is this attached to this, which is propanoid. Okay, we'll end the more on this